Hi lovely people, it's Richard here again. Today our discussion on calculus will be on derivative involving inverse hyperbolic functions. Last we have a video where we differentiate all the inverse hyperbolic functions and we came out with these results. So we said that the differential of sinh inverse of s is this, the differential of cosh inverse of s is this, the differential of tanh inverse of s is this, and the differential of sech inverse of s is that, then cosh inverse of s is this, then cosh inverse of s is this. Please, if you have not watched my videos on how to differentiate all this, check it out on YouTube. Today, before the video ends, we'll learn how to solve some problems that involve inverse hyperbolic functions. This will be a very interesting engagement, so please watch the video till the end. So our first question is, if y is equal to tanh inverse of sinx, we should find the y over dx. We'll use chain rule to solve this. So y is equal to tanh inverse of sinx. So we let u to be equal to our sinx. Remember, when we're doing circuit functions, the differential of sinx is cos x. So we differentiate this. Our du over dx will be equal to cos x. So this will change our problem here. So in place of sin x, we substitute our y will be equal to tanh inverse of u. Now differentiate y with respect to u. So what do we have? Remember, the differential of tanh inverse is 1 over 1 minus s squared. So the differential of tanh inverse of u will be 1 over 1 minus u squared. So our dy over du will be equal to 1 over 1 minus u squared. So from chain rule, our dy over dx will be equal to du over dx times dy over du. Please, very important. Now what's our du over dx is cos x. So cos x times what's our dy over du is 1 over 1 minus u squared. When we polish this, we have cos x all over 1 minus u squared. And remember, our u is sin x. So in place of u, we substitute sin x. So when we substitute, we'll have cos x over 1 minus sin square x. Remember, when we're learning cyclic functions, we said that cos square x plus sin square x is equal to 1. So we can say that cos square x is equal to 1 minus sin square x. So in place of 1 minus sin square x, we can substitute cos square x. So our dy over dx will be equal to cos x all over cos square x. So what are we having now here? You can see that one of the cos will divide this, we'll be left with 1 over cos x. And remember, 1 over cos is sec. Then we can say that our dy over dx will be equal to sec x. I hope you get it. So our second question says that given that y is equal to tanh inverse of sin 4x, we should find dy over dx. Please pause and try solving and see if you can solve. So our y is equal to tanh inverse of sin 4x. So what do we do? We use chain rule again. We let u to be equal to sin 4x. Remember how to differentiate this. Our du over dx, we differentiate the 4x, we get 4. We differentiate sin, we get cos. Then we repeat the angle. Now y will be equal to tanh inverse. In place of sin 4x, we put u because u is sin 4x. Then find dy over du. Dy over du will be 1 over 1 minus u squared. So from chain rule, dy over dx will be equal to du over dx times dy over du. So what do we have? We know our du over dx to be 4 cos 4x. So we have 4 cos 4x times 1 over 1 minus u squared. So when we polish it further, we get 4 cos 4x over 1 minus u squared. What's our u? Our u is sin 4x. So in place of u, we substitute sin 4x. So when we substitute, our dy over dx will be equal to 4 cos 4x over 1 minus sin square 4x. So remember when we were doing cyclic functions, we said that cos square 4x plus sin square 4x will be equal to 1. So we'll make cos square 4x as cos square 4x will be 1 minus sin square 4x. So in place of 1 minus sin square 4x, we substitute cos square 4x. So we can say that our dy over dx will be equal to 4 cos 4x over cos square 4x. So one of the cos 4x will divide one of these. We'll be left with 4 over cos 4x. You can rewrite that as 4 times 1 over cos 4x. See, 1 over cos is sec. Then we can say that 1 over cos 4x is sec 4x. So this will be 4 sec 4x. So this becomes our dy over dx. I hope you got the same answer. So our third question, please you can pause the video and try solving. They say if y is equal to sinh inverse of sihnx, you should find dy over dx. The same way again, so y is equal to sinh inverse of sihnx. What do? We let u to be equal to sihnx. Remember, when we're doing hyperbolic functions, the differential of sinh is cosh. So the u over dx will be equal to cosh x. Then, in place of, so our y will be equal to sinh inverse of, in place of sihnx, we substitute u. Remember the differential of sihnx. See, the differential of sihnx, sinh inverse of x, is 1 over the square root of 1 plus x squared. So the differential of sinh inverse of u will just be equal to 1 over 1 plus u squared. So in that case, we can say that our dy over du will go to 1 over the square root of 1 plus u squared. Then from chain rule, we can say that our dy over dx will equal to du over dx times dy over du. So what are we having there? So what's our du over there is cosh s. We have cosh x times what's our dy over du is 1 over the square root of 1 plus u squared. So we'll solve this further. We get cosh x over 1, the square root of 1 plus u squared. Remember, our u is sinx. So in place of u, we substitute sinx. So when we substitute, our dy over dx will be equal to cosh x over the square root of 1 plus, in place of u, so that will be sin square x. Remember when we were doing hyperbolic function, we said cosh square x minus sin square x is equal to 1. So what do we have? When we make cosh square x, I will have cosh square x is equal to 1 plus sin square x. Then you can say in place of 1 plus sin square x is cosh square x. So our dy over dx will be equal to cosh x all over the square root of cosh square x, and this will be equal to cosh x. The square root of cosh square x will be cosh x, so that will be cosh x. Cosh divided by cosh is 1. So our dy over dx is nothing but 1. I hope you got 1 as your answer. If you got it, congrats. So our fourth question say that if y is equal to x dash inverse of 7x plus 1 over 14 ln 1 minus 49x squared, we should find dy over dx. Look at this. Please, this is multiplying, so we use product rule to solve that. Then remember the differentiation of ln function. We reciprocate this function, differentiate it, and use it to multiply the reciprocal. So we can say that dy over dx will be equal to the differential of x. That means we differentiate them individually. Tanh inverse of 7x plus 1 over 14 dy over dx, the differential of ln 1 minus 49x squared. So I'll use product rule to differentiate it. So I'll keep x, differentiate tanh inverse of 7x. I'll keep tanh inverse of 7x and differentiate x. That's the product rule. So I want to differentiate this. I want to find the differential of tanh inverse of 7x. I want to do that. So I'll let u to be equal to my 7x. Our du over dx will be 7. What happened? So we can say in place of that, we have the differential. So in place of 7x, we substitute u. So we have the differential of tanh inverse of u. ddu over the differential of tanh inverse of u. Remember the tanh inverse of x is the differential of that is 1 over 1 minus x squared. So that will be 1 over 1 minus u squared for this. So we have this to be 1 over 1 minus u squared. So from product rule is saying that this is our differential d over dx of tanh inverse of 7x will be equal to this and this. 7 times 1 over 1 minus u squared, which will be 7 over 1 minus u squared. 7 over 1 minus. What's our u? Our u is 7x. So 7x squared, that will be 49x squared. I hope you get that. So the differential of tanh inverse of 7x is 7 over 1 minus 49x squared. So coming back to this, we can now differentiate. So we know that our dy over dx will be equal to, now I'll keep tanh inverse of 7x and differentiate x. If I differentiate x, I'll get 1 and use it to multiply tanh inverse of 7x. Then plus, now I'll keep x and differentiate tanh inverse of 7x. If I differentiate tanh inverse of 7x, I'll get 7 over 1 minus 49x squared. I took you through that already. So I have x times 7 over 1 minus 49x squared. Then plus 1 over 14 times, remember the differentiation of ln function. We reciprocate this function. Remember this is over 1. So we'll get 1 over 1 minus 49x squared. Then we differentiate this and use it to multiply. The differential of 1 is 0. Then the differential of minus 49x squared will be 98x. When we polish it further, this will be equal to tanh inverse of 7x plus 7x over 1 minus 49x squared. Then this, please, there is negative here, so this will be minus. So have minus 98x all over 14 bracket 1 minus 49x squared. I hope you get that. Please, the differential of 1 is 0. The differential of negative 49x squared will be negative 98x. So we can solve this. See, the LCM of this and this will just be that. So we can say this is further dash inverse of 7x plus, what's our LCM? Our LCM will be 14, 1 minus 49 x squared. So if this go here, we'll be left with 14. 14 times 7x will be 98x. Minus, this goes here 1 times that will just be 98x. So what do we have? We have dash inverse of 7x. 98x minus 98x is 0 over 14 times 1 minus 49x squared. So the whole of this will be 0. Then we can say that our dy over dx is equal to dash inverse of 7x. I hope you had the same answer. We'll solve one more question on this so that you'll be abreast with the concept. Please, before we solve our last question, remember to subscribe to my YouTube channel if you are here to, and share my video, like it, and please comment. Your comments keeps me going. Now the last question says that given that y is equal to cosh inverse of x squared plus 1, show that dy over dx is equal to 2 all over the square root of x squared plus 2. Please, you can pause the video and try solving this. After that, you compare your answers with mine. So we know y to be equal to cosh inverse of x squared plus 1. So we let u to be equal to x squared plus 1 using chain rule. Our du over dx will be equal to 2x. When we differentiate this, we get 2x. We differentiate 1 is 0. Now what next? We have y to be equal to cosh inverse. In place of this, we put u. So that will be cosh inverse of u. So our dy over du. Remember the differential of cosh inverse. The differential of cosh inverse is 1 all over the square root of x squared minus 1. So the differential of cosh inverse of u will be equal to 1 over the square root of u squared minus 1. So what do we have? Our dy over du will be 1 over the square root of u squared, the square root 1 over the square root of u squared minus 1. So from chain rule, our dy over dx must be equal to du over dx times dy over du. Look at it, the du divided du, then we have dy over dx back. What's our du over dx is 2x. So 2x times, let me use the dot, dy over du will be 1 over the square root of u squared minus 1. When we polish further, we'll get 2x all over the square root of u squared minus 1. Remember our u is x squared plus 1. So in place of u, we substitute x squared plus 1. Okay, so we know u to be x squared plus 1, so we substitute. We get 2x over the square root of x squared plus 1 in place of u all squared minus 1. So that's our dy over dx. What do? We can expand this. So we can expand, look at this, we can expand this. So let's expand and see what we get. X squared plus 1 all squared is x squared plus 1 times x squared plus 1. So this multiply this, we get x exponent 4. This times this will be x squared. This times this will be x squared. Then this times this will be plus 1. When we polish, we get x exponent 4 plus this time plus this x squared plus x squared will be 2x squared plus 1. So in place of this, we can substitute that. Remember, we have minus 1 there. So what do we get? We have our dy over dx to be equal to 2x all over the square root of x exponent 4 plus 2x squared plus 1 for this, then minus 1. So 1 minus 1 is 0. What is left? We'll be left with 2x over the square root of x exponent 4 plus 2x. Remember, this minus this is 0. 1 minus 1 is 0. So we can repolish this to have 2x all over the square root of, see, what is common here? S squared is common. I can bring it out. What's left? We'll have s squared plus 2. The square root of s squared is x. Then I can say that my du over dx from here will be 2x over the square root of s squared is x. The square root of s squared plus 2. Look at this. This x can divide this. What is left? We'll be left with 2 all over the square root of x squared plus 2. So we have proof what the access to proof. We got our du over dx to be 2 all over the square root of x squared plus 2. So that's specified that. So we can say as required. As required. Please, we'll end it here today. Remember to subscribe to my YouTube channel if you are here too. Until we meet again. Bye-bye.